So guys, there is actually another way to find the support reaction in this given particular beam and its loadings, and that is via integration. So the only thing that we must know first, or the prerequisite of this, is that we must now know that the general equation of a line is defined or given by y is equal to a plus bx, and the area under a curve is just the integral of that function dx. Right, with these two, we can have another way to solve this. How? And this is how. First, we must pick an origin from where we will define our x and y. So let's say I pick the origin here at b. Say this is my y. So kunuhay ako y. And then this is my x right here. And now what? Since the equation of a line, general equation, is equal to y is equal to a plus bx, we only need at least 2 points so we can define this change, uniform varying change, right, in this loading. So since our origin is right here, we can say that when this x of us is equal to 0, then our loading is going to be what? 40. That is 40. And also at x equals 20 here, sorry, at x equals 7, this is 7, this is our origin, so we run to the right 7 units, or 7 meters, we got 20 kilonewton meter. So y equals at x equals 7, y is equal to 20. With this given information about this loading via our calculator mode, and then this statistics mode, that is 3, and then linear, since we're defining an equation of a line, we can now solve for the equation of this. And again, that is just equal to y is equal to a plus bx. So here in our calculator, we will input the corresponding values of x and y's. So in our first column, we have 0. Next is 7. We get 7. And then here, at x equals 0, we said that the loading is equal to 40 kilonewton per meter. So we input here 40. 40. And then here, at x equals 7, we have 20. Now after putting our data in that statistics mode, we press this CA, and then we go to the apps. Then click this 8, the regression. Sorry, excuse me. Regression, and then this will give us the value of our a in our equation y equals a plus bx. So that is equal to 40. So this guy is 40. And then RB. So we press AC again. Then go to apps and regression. And then to just B. And that is equal to that value, or if we press this F2D button, that's in fraction form, it's going to be negative 20 over 7x. So this is now the function defining this change in our uniform load. So that is equal to y is equal to 40 minus 20 over 7x. We can check that by inputting here in our calcu 40 minus 20 over 7x. To check, we know that at x is equal to 0, our value must be y. The loading must be y. So okay, it gives us the correct value. Then at x equals 7, our value must be 20. So yeah, it's correct again. So indeed, this is our function of this. Now, how do we find the reaction now at C with only this via this function and integration? How? This is how. First, we need to define again this as the overall magnitude of this. And what's this value? What's this value? It's just the area of this overall trapezoidal shape. So how do we find the area under a curve given that we have this function y equals 40 minus 20 over 7x? That is just the integral of this value. Alright? And that is from, we know that this is our origin 0 to 7. So this is the entire span of this loading. So we integrate that, we get the area. The area of this function is going to be the integral of 40 minus 20 over 7x dx from 0 to 7. And if we evaluate that via our calculator, we get this. Where's the integral? That is equal to 40 minus 20 over 7 then x. Then here we have limits. Our limits are, that is 7 upper, then 0 here. So press equals, and we got 210. Alright, so this is 210 kilonewtons. So this value is 210. Alright, now how about its moment arm? So the location of this 210 with respect to this origin, we can denote that or locate that by x value. Alright, therefore if we some moment about A, that is of course equal to 0, in order for this to become in equilibrium, we get this RC times 8, that is equal to this value 210 times, what is moment arm about A? That is 3 plus x. So that is 210 3 plus x. Alright, but no, we can't directly say that this is 210. Instead, we can say that this is integral of this value 0 to 7, the one we used a while ago, 40 minus 20 over 7x dx, or times 3 plus x dx is 1. That's equal to 8 RC. Or in other words, RC, or the reaction at C, is just 1/8 of this integral. Dx. Alright. Now if we input this all in our calculator, we get there 0 to 7, and then we add here 3 plus x, 3 plus alpha x, right? Then what do we got? Times 1/8 this value times or divided by 8, that's the same. And what do we got here? We get that, plus press equals, and boom, 25 over 12, or that is 160.42. So RC is equal to 160.42 kilonewton. This is the reaction here at C. So all we had, or all we did, was to define this function in terms of equation of a line, or this varying change and we pick this as our origin. And then similar to geometrical approach, we will get the area of this, so we can have moment about a to get this. We also did that, but in an integral way, or integration way. So that is integral of this function from 0, this origin, to this 7, and then its moment arm is just 3 plus the location of this. The location of this function, or in other words, the centroid of this is just this x, right? And then that is, since our moment, or we take moment about a, then we add this 3, so 3 plus x, that is here, and we got this value. Right, that's it. Thanks for watching.